Where it becomes much more easier. Today we'll be looking at hydrocarbons. We'll be looking at the definition of hydrocarbons, the origin, the root, and some examples of hydrocarbons. When we hear the name hydrocarbons, what should first come into our mind is the word hydrogen and carbon. So the root name of this hydrocarbon is from hydrogen and carbon. So we remove the hydro and we put this to form hydrocarbon. So there is a connection between each of these elements. The symbol for carbon is C and the symbol for hydrogen is H. So there can be a connection, a kind of bond formed between these two elements. So carbon and hydrogen can form a bond. Since carbon has an electronic configuration where we have 4 valence electrons. That is to say, the valence electron here are 4. It means carbon can be bonded to 4 other atoms, can form covalent bond with 4 other atoms. So if you have this, carbon can form a bond with hydrogen, it can form with another hydrogen, form with another hydrogen, and form with another hydrogen to make this stable. Since hydrogen is a positron, or let's call it a proton, it needs an electron from the carbon atom to attain its stability. Hydrogen has a configuration, has a symbol of this nature. That's a normal hydrogen has something we call 1 and 1. But when we talk about deuterium, we have something we call 2, 1, and it can be what? 3, 1. We call this one deuterium and we call this tritium. But for a normal hydrogen in a ground state, without introducing some isotopes, we can have it in this nature. So if hydrogen is a positron or a proton, meeting with this carbon here is going to form a covalent bond because it's in need of electron from the carbon, and the carbon is also in need of the positron here to attain stability. So the two of them can join or exist together to have stability. For that, there is an overlap between these bonds. What we call overlap is if we want to be formed, if this is for carbon and this is for hydrogen. The two of them must have to mix together before they can form a bond like a covalent bond. So there will be a mixing of this nature. And what we mean by this, when this mixing happens, we will see that a particular bond will be created between the two of them, and this bond that will be created here is an electron-rich bond. And this kind of electron-rich bond, we call it a sigma bond. A sigma bond, that is the symbol, and the name is sigma. Sigma bond, and it is an electron-rich bond. So thereafter, apart from this hybridization that has happened, we also have families of hydrocarbons. We have families of hydrocarbon or branches of hydrocarbon. So hydrocarbon is divided into 2. It's subdivided into 2. One we call the aliphatic hydrocarbon, and the other is the aromatic. Now, the aliphatic hydrocarbons are straight chain hydrocarbons, while the aromatic hydrocarbon can be a branch but contain double bond. But the aliphatic has no double bond. Example of families of alkanes of aliphatic is the alkanes family. The alkane family does not have any double bond. And this aromatic, they have a sweet smell. Example of aromatic hydrocarbon, we have benzene, toluene, we have the anthracene, we have the naphthalene. So all these are examples of aromatic hydrocarbons. The particular characteristics they have is that they have double bond. That is, they are not saturated. While these ones are saturated, So if you are asked to give characteristics of all the aromatic hydrocarbons, saturation is there. So they are not saturated, while these ones are saturated and they are straight chains. That is that about that. So examples of the aliphatic hydrocarbons, we can have the methane, we can have propane, we can have ethane, so on and so forth. So this is all you have to know about the branches of hydrocarbons. In our next video, we'll look deep into one of the contexts of the hydrocarbons, which are the alkanes. We'll discuss more on that, then we'll get to know the properties of this. If you enjoyed this video, please like, subscribe, share to your friends so that they can also learn from what you've learned so far.